Fires of any scale tend to produce a certain amount of smoke, a variety of different particles, including small bits of unburnt fuel, which eventually disperse into the atmosphere. And looking at data from satellites out in space, scientists in Israel have shown that smoke from the late 2019, early 2020 Australian wildfires actually travelled up beyond the lower atmosphere, known as the troposphere, and into the stratosphere, that's above where clouds gather and planes tend to fly. Up here, these smoke particles stick around for longer, where they can absorb or scatter incoming energy from the sun and potentially alter the amount of energy that reaches the Earth. And in a paper published recently in the journal Science, these scientists have outlined a combination of 3 factors that they think has led to this happening. My name's Katie Haler, and I spoke to author Itan Hiosh from the Israel Institute for Biological Research.
Bushfires happen in Australia every year and all over the globe all the time, but we rarely see occasions where smoke from the bushfires manages to reach the stratosphere.
What experiments did you actually do, or what data did you look at?
We used the MODIS sensor, a spaceborne sensor on board the Aqua satellite. MODIS actually covers the Earth on a daily basis, and it provides the aerosol optical depth, AOD, which is a measure of how many aerosols there are in the atmospheric column. MODIS provides daily averages and monthly averages of this AOD. And what we discovered is that at early 2020, there were anomalous AOD values all over the southern hemisphere, the result of the massive bushfires in Australia.
What were they anomalous to? Because you've got to compare this with something to make a judgment on it, haven't you?
Yes, exactly. MODIS started to acquire data at 2002. So we compared the data of early 2020 to the average of the previous 17 years. And we saw that the AOD values of early 2020 were 50% higher than the average values for the previous 17 years.
Why do you think so much aerosol has ended up in the stratosphere?
This is basically a combination of few factors. First of all, Australian bushfires at early 2020 were enormous, but they were unique in the sense that they were also very intensive in the southern parts of Australia, closer to areas where the tropopause is lower. The tropopause is actually the height of the troposphere, and around the equator in the tropics, the tropopause can be up to 17 kilometers. But if we go to higher latitudes, such as 45 degrees, the tropopause decreases very, very quickly, and it can reach height of 10, 12 kilometers. So basically, the fact that the fires occurred at the southern parts of Australia already created favorable conditions for aerosols to penetrate to the stratosphere because they needed less energy in order to reach the stratosphere. And not only that, also the southern parts of Australia are relatively close to what is called the mid-latitudes cyclones belt, very intensive convective activity. And this convective activity lifted more aerosols to the upper parts of the troposphere and into the stratosphere. So we believe all these conditions together created a very, very unique situation.
Why is this relevant?
Once aerosols reach the stratosphere, their lifetime is much, much longer. Their effect is by an order of magnitude larger. Their main interaction when they are in the stratosphere is they either absorb or scatter solar radiation, and they affect the amount of radiation that finally reaches the surface. It relates to climate change and to the energy balance of the Earth because a large amount of aerosols in the stratosphere can change the energy balance of the Earth. And this is one thing that we saw in our study.
So crucially then, how did this large amount of aerosol change the energy balance? What did you actually find?
Well, we found at early 2020 there was a change, effect of cooling of 1 watt per square meter over oceanic cloud-free regions.
Do you think the cooling effect is positive?
It's very hard to say because climate is such a complicated system. There are many, many feedbacks, and we can't really be positive that it's a positive thing, this cooling effect.
What do you think people should take away from this study?
Well, I think that people should be aware that these fires might become more frequent and more fires might occur at the southern parts of Australia. Not only they are affecting what's going on the surface of the earth, but they might have impact on what's going on in the atmosphere.